Hello and welcome again to my Physics 1 topical video short lectures. Today's video I'm going to be talking a little bit about further prerequisite and preliminary information, background information for the course. In some sense, stuff that I would have hoped that you knew before coming here, but that not everybody always does or everybody remembers. And that is, in today's video, right triangles. So again, this is something that you should have learned about in your geometry and trigonometry course before taking this course. But for some of you, I know it's been a little while. So let's get into it, shall we? It has the very odd title of right triangles today, and really this is about doing a few things. One is just analyzing the angles and sides within a right triangle, and the other is, what if it's not a right triangle? What do we do then? Okay, so right triangle, as a reminder, you basically have a shape like this. So here's our triangle, and one of the angles is a right angle. So this angle is 90 degrees. I'm going to, for convenience, label this angle as theta. I'm going to label these sides as A and B, and this one as C. But these may be represented by hypotenuse. The longest side is the hypotenuse in a right triangle. This side right here may be represented as the side opposite to theta, and this side is the side adjacent to angle theta. All right. So now that we've done those, what we want to do is see how these are related to each other. Well, you all should be very familiar with the Pythagorean Theorem. So the Pythagorean Theorem says essentially that the hypotenuse squared is equal to the sum of the squares of the two sides, a squared plus b squared. Okay, that's another way of saying that c is equal to the square root of a squared plus b squared. This is not the same thing. I'm going to go ahead and write this out now. This is absolutely not the same thing as just a plus b. Okay, c squared is a squared plus b squared. C is square root of a squared plus b squared. It is not the sum of a and b. Okay, second property for this right triangle is the area. Let's say that the area is given by A. Well, A will be 1/2. The area, big A, is 1/2 of the base, that's little a, times the height, that's big A. That's little b. Okay, so that's your area. And now the last property is basically the relation between angles. Let's say that this angle right here is angle phi. So another property here, angle theta plus angle phi must add up to 90 because all three angles within any triangle add up to 180. So one of the sides is already 90 degrees, the other two angles have to add up to 90 degrees. This means, for what it's worth, that their sines and cosines are equal. So sine theta is cosine phi, and sine phi is cosine theta. That's a consequence of this relationship. Okay, so now let's focus on theta. So sine of theta is going to be side length B divided by side length C. Cosine of theta is going to be side length A divided by side length C. And tangent of theta is going to be side B divided by side A. It's always the sine over the cosine, so you could also say sine theta over cosine theta. If we look at angle phi, it's sort of the other way around. Sine of phi is equal to cosine of theta is A over C. The cosine of phi is equal to the sine of theta will be B over C. And the tangent of phi is equal to what's called the cotangent of theta. It is basically 1 over the tangent of theta, and so that means that it's going to be A divided by B. Now there's a mnemonic that goes with those angle relations. So ka toa. Okay, this means sine angle equals opposite over hypotenuse cosine angle equals adjacent over hypotenuse and tangent of angle is opposite over adjacent. Okay, one last little sort of factoid, if you will, is that if you know the lengths of the sides and you're trying to figure out the angle, then on your calculator, the button to get from a cosine to an angle or from a sine to an angle is called arc sine and arc cosine. So arc sine is represented usually as the sine minus 1 button. Arc cosine is represented by the cosine negative 1 button. And arc tangent is the tan negative 1 button. These three functions, these give you angle if you have values for sine angle, cosine angle, or tangent angle, respectively. Finally, one last important property with sines, cosines, and tangents. They're bounded. So minus 1 is less than or equal to sine theta for any theta, less than or equal to plus 1, and same as cosine, such that cosine squared theta plus sine squared theta is 1. That's true for any angle, actually. And that's basically the Pythagorean Theorem applied to sines and cosines. You will need, however, to make sure that you are correctly in degree mode or radian mode to get the angle that you're looking for. I suppose another kind of important thing to note, so I've given the bounds here, and so another important note is to remember cosine of 0 degrees is 1, sine of 0 degrees is 0, cosine of 90 degrees is 0, sine of 90 degrees is 1, and then you also have 180 and 270 degrees, so cosine 180 degrees is minus 1, sine of 180 degrees is 0. Cosine of 270 degrees is 0. Sine of 270 degrees is -1. And you might review the unit circle for more such relations, but that's all that I'm going to do with those for now. I wanted to give you a sort of your turn to play before moving on to the last thing. All right, so here's a right triangle. I've even defined an angle theta within the right triangle for you. It has two side lengths given. Well, one of them is 8.4 centimeters, the other is 5.2 centimeters. And what you need to do is determine the hypotenuse, that's this side, the value of the angle theta, maybe in degrees, and the area of this triangle. So go ahead and pause the video here and calculate those things, and then check your answers against mine. All right, so we'll start by determining the value of the hypotenuse. So Pythagorean Theorem says if we label this C, this A, and this B, it says that C squared is A squared plus B squared. Okay, so that means that the hypotenuse should be square root of A squared plus B squared. So that is the square root of 8.4 centimeters squared plus 5.2 centimeters squared. And so I'm just going to enter all of that into my calculator. I will round to significant figures at the end. If you haven't already watched it, you should watch the videos on significant figures if you are lost as to what I'm doing there. So if I take 8.4 and I square it, I get 70.56 square centimeters. 70.56 centimeters squared. And actually, significant figures wise, this would round to 71. If I take 5.2 and I square it, I get 27.04 centimeters squared. And that would round to 27. Both should end up with two sig figs. Okay, so I add 27.04 to 70.56. I end up with 97.6 square centimeters. So C is the square root of 97.6 centimeters squared. And again, this should be rounded to 98. There's two significant figures there. So I take the square root of that, and I get 9.879271228 centimeters. And again, I said this should be rounded to two significant figures, so this digit would round up. That means that my hypotenuse is approximately 9.9 centimeters. So we'll just write that up here, 9.9 centimeters. Okay, so that's my answer to the first thing. Second item is to find the value of the angle theta. So I actually have all the sides now, so I could in principle use sine, cosine, or tangent, and they should all give me the same answer. I'm actually going to use tangent because it's using the digits or the numbers that I started with. And so if for some reason I accidentally miscalculated this, then that would not affect this answer if I use tangent. So tangent theta is opposite, that would be B, divided by adjacent, that would be A. So that means that the tangent of theta is 5.2 centimeters divided by 8.4 centimeters. And if I plug those two things in, so 5.2 divided by 8.4, I actually get 0.619047619. So then I need to do the arctangent. So theta is approximately the arctangent, so tan -1 of well, this whole number. I'm not going to rewrite it here. And again, I had 2 sig figs here, 2 sig figs here. My answer should have 2 sig figs. So I push the tan -1 button. I put the digits in, and I get 31.75, etc. So at 2 significant figures, this is 32 degrees. So approximately 32 degrees. The last part was the area. A equals 1/2 of base times height. So that's 1/2 of 5.2 centimeters times 8.4 centimeters. So half times 5.2 times 8.4 gives me 21.84. So 21.84 square centimeters. And significant figures rules. I have 2 digits here, I have 2 digits here. This is a half, but this half is an exact half. The area of this triangle is exactly half of the base times the height. So this is not considered in the significant figures. We only look at this digit and this digit. The answer therefore has to have 2 significant figures. 21.84 would round to 22 square centimeters. So that's what the area of this triangle is. Okay, last little thing. What happens if you have a triangle that isn't a right triangle? You know, maybe you have a triangle that is somehow like this. So there's no right angles anywhere involved in this triangle. Maybe you happen to know the value of this side and this side, and you would presumably know some interior angles somewhere. Like maybe you know what this angle right here is. Okay? And maybe you happen to know this angle right here. So we'll call those theta and phi. How do you resolve this? So you'd need basically 4 pieces of information. You could do 3 sides in an angle. You could do 2 angles and 2 sides. In any case, what you would do is you would draw for yourself one line right here that represents the height of this triangle. You would define this one maybe as h, and it's the height because this right here makes a right angle. All right, so now how do you figure out what the sides are? Well, you know the value of A and you know the value of this angle. So this A becomes the hypotenuse of this little right triangle here whose height is h. And so you could say that the sine of theta is h, the opposite, over A, the hypotenuse. Okay, so now you've solved for h. Then, since you have h, you can now figure out some sides on the inside. So maybe, for example, you want to figure out what this angle right here is, gamma. Okay, well, the tangent of gamma would be the adjacent side divided by the hypotenuse side. Okay, so this is like step 1, this is step 2, step 3. That means that this angle right here, we could call this angle beta. Gamma plus beta is equal to phi. And so that basically in turn means that beta is phi minus gamma. Okay, so now we've solved for that angle beta. What is this side length? Let's say that this is like the ultimate mystery, this side length. So our next step may be to figure out what the values of this side right here, we'll call this side D. We could call this one C. Well, h squared plus d squared is a squared, or for that matter, I could use either one of these angles. So cosine of theta is d over a, either one, and therefore d is a cosine theta. That means that this side, the thing that's left over here, this side would be b minus d. Okay, and so now I have a right triangle in which c squared is this side squared plus the other side squared, b minus d squared. And that's it. So this would be step 4, this would be step 5. Okay, or I could use that the sine of beta the cosine of beta is h over c. And so we could also solve this by saying c is h over cosine beta. Okay, so you can solve it in 4 or in 5 steps. I'm not going to do it with any particular numbers, but I have now shown you how to do it. And so that will end this video. We've already gotten a little on the long side for today. So thanks for watching, and hopefully that helps you with basic triangles and the geometry thereof.